Hello, everyone. We'll wait just about one more minute here, let a few more people join, and we'll get the webinar started. All right. Good morning, good afternoon, good evening to everybody, and welcome to this webinar presented by Cirrus Link Solutions. Our topic today is how to solve secure operational data integrity and availability with MQTT. Real brief introduction to Cirrus Link Solutions. Cirrus Link was founded in 2012 with the intent of providing MQTT-centric software for industrial automation solutions. I had the great opportunity to be one of the co-inventors of MQTT with Andy Stanford Clark almost 23 years ago. And what was interesting to us at the time is that MQTT was actually invented on a project with Phillips 66 for mission-critical real-time SCADA systems. But it's almost like over the last 20 years, it was invented for operations, adopted by IT, and now we're ready to bring all that together, if you will. We've got over 70 man-years of experience working with MQTT, and the development team at Cirrus Link created the initial Sparkplug-B specification. We've helped over 35 OEMs in implementing MQTT and Sparkplug, and in 2015, we became strategic partners, one of only two, with inductive automation. This September will be 5 years since we introduced our first module, MQTT Engine. Now, we've now developed a whole line of MQTT-centric modules as well as cloud connector modules for the Ignition platform. I'm joined today with two guest presenters. Alan Ray, who's at one of our end customers. He's also was key in establishing the Ignition cross-industry collective, where Alan has companies from different vertical sectors. They get together about once a quarter and they talk about subjects like this, as well as any other lessons learned, best practices, or innovation across the industry using Ignition. Benson is a VP at Opto 22, and he's going to have some really cool demo for you towards the end of this webinar. I'm Arlen Nipper, I'm the CTO with Cirrus Link, and I'm joined by Nathan Davenport, who is one of the senior software engineers at Cirrus Link, along with Kurt Hoganade. Now, very quickly, our agenda is, first we're going to start with what is the problem? You know, what is this webinar about? What's the problem that we're trying to solve? Then using that, we're going to look very briefly at MQTT and Sparkplug as a component. We're going to look at MQTT Security. And then Kurt's going to talk briefly about the business drivers that we're seeing in the market around ISI 95, the Purdue Model, and MQTT. Finally, Benson's going to follow up with a very cool presentation on edge security and a demonstration of how that's applied with the Opto 22 product line. So with that, we're going to start with Alan discussing what is the problem that he sees from an end user perspective. So with that, I'm going to turn it over to you, Alan.
Thank you, Arlen. So I've been asked to come in and kind of share the story of our journey, specifically around trying to get control system data to the cloud while being really within the Purdue model, which is what our company, which is a oil and gas company. We operate in California. We have about 10,000 wells, and we're distributed throughout California, different areas. And so we're very we're very much a targeted company, state-sponsored targeted company in the cyber world, so we've been on a journey for the last, I would say, the last 2 years to try to figure out how we can get data from the edge that is associated with our control system back on the prem. We've had some success in getting third-party companies to come out, put a device in, go to their cloud, and then come back onto a cell phone or a tablet that you can get some of that data. But we've never been able to get the data from the edge back into our system. And so we started a journey 2 years ago working with Azure. We brought in the Microsoft Black Belts, and we went on this journey on architecting a solution that would allow us, and keep in mind, this was only that for us to be able to read data, not control, but took us 1 year and we didn't get the approval. And so part of that journey happened, or what happened in that journey was that Microsoft, in the middle of our journey, deprecated some of their technology, which we were depending on, and made us really step back and kind of punt. And when we came to the end of our journey with the direction we were headed, which was we were trying to get the methodology using IoT Hub and the edge device and how we were going to do that, and making sure that we were the architecture, the methodology was using the technologies in the cloud and the security in the cloud. Well, what we found out was security wanted to do a very deep dive into every bit and piece of that technology and wanted to know what the opportunities were. And so after a year of really beating our head against the wall and never having the success of getting to a place where we could even deploy a pilot to test anything, we completely threw out all that work. And that's when I began to team up with Arlen and Benson and really start thinking about how could we do this in a way that we can control the technology, we can control the methodology, and we will leverage the cloud and allow it to change and make and increase in opportunities, but be able to always take advantage of those, but never have to worry about, hey, if they make some change or they have some technology or some security and then they change it, we're going to be impacted. And so what we did was we set up what we like to call guardrails. And so our guardrails very simply state that you have to have an edge device that can deploy and install a certificate from our company. It has to have ignition embedded on it. We are using a onboard firewall, so the Epic, the Rio, both of these devices have onboard firewalls that allow us to block all incoming ports on that edge device. We then whitelist only the ports that we want to communicate out of that edge device. Then in Azure, we will whitelist the Azure IP addresses, which is also the IP address has to be a non-routable IP address. And then we use MQTT Secure, so we're encrypted. All incoming ports are locked down. MQTT is secure, and we have whitelisted in Azure. And because we are now MQTT, we are going to what our service bus is, which is RabbitMQ in the cloud. So we have a single endpoint, our error certificate in the endpoint at Azure, our error certificate is in the edge device, and we are completely locked down so that once that MQTT connection is made from the edge device, is persistent, it will stay open, and now I have the ability to subscribe and then get the updates from anything, or publish, I'm sorry, I publish my tags, but yet at the same time, if those tags change, I get the updates. So now I'm not just reading, now I'm securely reading and able to send data back down into that device. And for the first time, we were able to get that approved through security. We have it set up in a pilot in the field, and we're moving data today using that methodology. The other issue that we have been working on the security piece is zoning and conduiting. So as far back as 5 years ago, I began to work with different companies trying to figure out how we can protect our legacy equipment. We have 1,400 devices in the field that are Ethernet connected, and how do we protect those devices in a way that they're not accessible from the network, but yet I can still get access to them. So 5 years ago, we started to see white papers on the ability to zone off legacy equipment. And so multiple, Opto 22 had a white paper. I don't know when theirs came out, but I saw theirs as multiple companies had these devices that you could place in front of legacy equipment. It would talk to the legacy equipment, and then it would publish, or it would communicate via TLS or some other mechanism that would give you more security so that the legacy equipment was protected. Well, the reason that we never used it, well, there's two reasons. The first reason is the moment I put that device in front of my legacy PLC, I can no longer access that device. I have to have a technician drive to the field, get out of his truck, plug into that PLC. And we don't have the resources, and we don't want to risk the safety of having to have people have windshield time if it's not necessary. But there was a second problem that also happened. The second problem that happened was I had to start creating a mapping table. So I've got a piece of equipment I put in front of a legacy device. That legacy equipment talks to this new security device. It grabs all of its tags. It converts it to some other protocol. And then I'm now having to manage a mapping table inside that device. So with help from Arlen and help from Benson from Opto, we have effectively been able to create a zoning and conduit device, a proxy device, a port forwarding device, whatever you want to call it, that it's the Opto 22 Epic that you can put in front of a piece of legacy equipment. Ignition is embedded in that device. So Ignition now on the segmented network will talk to that legacy equipment. On a completely separate segmented network, Ethernet adapter on the device, I now go the same methodology that we're using to go to the edge, we're going to use within our trusted network, which is we're going to lock out all incoming ports. We're going to go out of that device, MQTT, using Ignition and the Cirrus Link modules, and we're going to go from a central server in a server room that's polling those PLCs every second to a true pub sub environment that I am now publishing and subscribing. And the benefit of that gives me is it allows me to now, I'm MQTTS. So now I have just taken out the opportunity of a man-in-the-middle attack. So I can no longer have to worry about if somebody can get in the line, they can see that Modbus TCP or they can see that SIP protocols. And that's been a huge benefit for us to be able to not just be able to segment off that legacy equipment, but it gets better. But now using MQTT, I can send a command to that Epic. That Epic will initiate a firewall rule that will allow me to port forward the two segmented networks so that my technician on a time basis can get access to that legacy equipment remotely for a period of time. That window closes, the complete firewall rule that did the port forwarding is destroyed and is gone. It's not there. We're not disabling it and enabling it. We are building it and tearing it completely out. So it's not even there to be manipulated. You have to be able to functionally call that using MQTT and the broker. And the last thing I'll talk about quickly is our journey around PLC migration. So 3 years ago, we started a big project, multi-million, tens of millions of dollar project, where we are taking our critical PLCs and we're migrating those PLCs into a more secure platform, getting rid of that legacy PLC equipment. What's interesting, if you look at our last 3 years on our journey of PLC migration, we've migrated, I don't know, maybe 4 or 5 critical big PLCs. But the money that we spent to do that, I could have bought multiple Epics, probably 7 or 8 of them, and put in every single one of our PLC cabinets. Now, I still have the problem of the legacy equipment, the failure rates, and the things like that, but I can now actually secure our PLCs using this port and forward opportunity, leveraging the Cirrus Link modules, leveraging Ignition, allowing us to go to pub sub, no longer polling, and all the benefits we receive from moving the IO down to the actual physical location. And with that, I will hand it back to, I think, Arlen, but I'm not sure.
Hey, thanks, Alan. Appreciate it. That was great. So real quick, let's just kind of set a baseline here of MQTT and Sparkplug. So again, as I mentioned, MQTT has been around for 23 years. It's become a de facto standard within the cloud ingest of IoT data. And the beautiful thing about MQTT is that it's really simple. You create a topic and you publish on that topic, and that topic can have a payload attached to it. So the great thing about MQTT is you can publish anything you want on any topic. The bad thing about MQTT is you can publish anything you want on any topic. And if we truly are going to grow or scale at the speed that the Internet of People did, we have to take a look at that. So the Internet of People took 2 open technologies, HTTP and HTML. And with those 2 technologies, people could get their hands around that, they could get access to the code, and they could start innovating, and the Internet of People exploded. We need to have that same methodology for the industrial Internet of Things. Now, we have this dominant transport called MQTT, but what we need is that HTML of the Internet of People. And that's what we're striving to do with Sparkplug, is that gives us the ability then to be interoperable across different solution providers, across different OEM equipment providers. Now, real quick, top level down is that, well, what does Sparkplug do for me? Well, having that central topic namespace defined basically gives me plug and play auto. I can go out, I can subscribe to a broker, I can do a wildcard subscription, and I can discover what's out there and where it came from. Well, now I'm able to do that. I've got the ability now at the edge of the network, and in my particular control system, I can start defining models and assets at the edge using the tools that I've got with the ability to put together a UDT. Now I can literally publish that model from the edge of the network. Now, once I've got that model published, we needed a way to create a measurement or a process variable object. For the last 40 years, we've been dealing with register value pairs. We've got a PLC register and we've got a value. We don't know what that is, so we're going to double click on it. We're going to give it a name, we're going to give it engineering units, we're going to give it engineering ranges, and every time another application wants to tap into that data, we've got to do that again and again. And so what we're striving to do is move as far to the edge of the network to define a single source of truth and publish that, and then all of the business systems, in addition to the operational system, will have the ability to automatically discover what we're publishing. What is that process variable? What are its engineering units? And then finally, with state management defined within Sparkplug, that lets us do report by exception, bidirectional command and control. And one thing that's been very interesting is that I said that in 2015, we introduced MQTT engine. And people were going, well, hey, you know, when the network goes out, we're still getting gaps in our data and gaps in our trends. So we figured out that I know the state of my MQTT session. I've got an object containing my measurement, so I could put those in a store and forward queue with the timestamp. So now when my MQTT network comes back online, I can publish all of those tags that we would have lost in any other methodology. So with that, on the right side, I've got all of the protocols and the ability to interface to my brownfield existing legacy equipment, get that into my Ignition or Ignition Edge infrastructure, use the tools in Ignition to create a model, i.e. that single source of truth, instantiate that model, creating an asset, and then that asset has the measurements that I have. So now I've got this notion of tools on platforms, not coding on operating systems, being able to define my models at the edge, providing a single source of truth for all of the line of business applications that want to consume our operational data. Now, real quick, across what we've been doing with MQTT Sparkplug and the modules that we sold, this is our breakdown of the industrial sectors that we're in today using MQTT and Sparkplug. As you can see, I know that this year we're going to have huge growth in the healthcare sector, food and beverage, logistics, but you can see all of the industries that we're in that are leveraging MQTT and Sparkplug. So with that quick introduction, I'm going to turn it over to Nathan, and Nathan's going to talk about MQTT Security. So I'm going to give you the keyboard and mouse right now, Nathan, so you should be good to go.
Great. Thank you, Arlen. Hello, everyone. Bear with me. Small technical difficulties. There we go. Sorry, I'm having trouble with the slide deck here.
I can advance it for you, Nathan.
Would you? I seem to be having a problem driving the slide deck. Thank you for that. Thanks, Arlen. So let me start by just describing the types of clients that we're trying to secure here. So we have edge clients on this slide here, edge clients on the right, host clients on the left. The edge clients, right, they're connected to your SCADA and operations platforms, right, in turn connected to your PLCs and your RTUs, connected to your edge gateways, connected to your native devices. Your host client on the other side of the MQTT pipeline, also the consuming client is consuming data to be sent off to another SCADA system, an MES, ERP, time series database, any number of cloud services, right? Any third-party application that may have an MQTT connector available. Arlen, can you advance that for me, please? Thank you very much. Okay. So let's talk a bit about the edge client connectivity. So we are going to make a TCP/IP connection from the edge over to, in this particular case, one of many MQTT servers. Now, in a typical fully redundant system, you're going to have multiple MQTT servers, right, operating in parallel, and the edge client is going to connect to any one of these, usually the first one available. We have the firewall at the server side. We have a firewall at the edge side. No open inbound ports are going to be required at the edge. And we're going to be able to make an outbound remote originated connection from the edge client to the MQTT server over TLS. And as I said before, the edge client is only going to connect to one of these available MQTT servers, right? This gives you the redundancy. If one of them goes down, the edge client is simply going to walk to the next MQTT server available. Okay, go ahead, Arlen. And the only port that needs to be open server side is going to be 8883. That's the typical MQTTS port. And again, connecting over TLS with the appropriate certs in place, both at the edge and at the server, we're able to secure your connection and ensure that your data is encrypted over this connection. Now we'll talk a bit more about host client connectivity. So here we're showing the host client on the right, and the collection of servers on the left, firewall at the server side. Again, the only port that needs to be open here is going to be 8883. So this host client, a little different than the edge client, it's going to make a TCP/IP connection over TLS, right, to all available MQTT servers. Now, in this redundant environment, the host doesn't necessarily know which clients are connected to which servers, so it's going to consume data from all, and it doesn't really care exactly which server a particular edge client is connected to. Okay, so after the TLS session is established, MQTT authentication is going to happen via username and password, right? There's two things that we want to call out here, two best practices that we need to be sure that we're following. So do not use non-TLS connections, right? As Alan described earlier, the last thing that we need is somebody to compromise your network and then end up getting your username and password in plain text. And then we're getting closer to a game over scenario here. And do not allow any anonymous connections. There's really no reason for it, and we don't recommend that you do so. The MQTT server access control list. So this is the kind of the authorization layer, if you will. This is going to, the ACL is going to allow you to define policies for a particular client or set of clients on exactly which topics these clients, one or many, can publish and subscribe on. Now, it's very flexible. You can set this up such that you have, one ACL per client, really, if you want to. You could have an ACL for a group of clients, edge clients. You can limit a particular ACL so that it's read-only or ingest. You could, within the context of Sparkplug, via ACLs, be able to lock down such that you can only publish and subscribe maybe by a Sparkplug group, ID, edge node ID, device ID, and so forth. So the main point that we're trying to drive home here is that in order to protect your operational data, you need to be using MQTTS. You need to have the appropriate certs on both ends, right? Client and server, and you need to be connecting over TLS. And with that, I'm going to hand you off to Kurt, I believe.
All right, thanks, Nathan.
Thank you.
So, Kurt, I'm going to give you the. Oops, hang on.
You just give me control?
Not yet. Hang on.
Anyway, well, Arlen gives me control. I want to talk about, so there's a lot of business drivers going on in the marketplace, and there's a lot of demand for data. Arlen, you still got control in publishing, so I'm not sure.
Huh. My GoToMeeting control panel. So Chris, can you see if you can give Kurt control? I'll go back into the.
Well, I go back in presentation mode, yeah. So anyway, so just as a, go back one, there we go. So there's a lot of market drivers that are happening with demand of data in the marketplace today. There's a lot of consumers wanting data. You're getting more demand from your CTO or the business units and IT to get data from these OT networks. And it's driving a lot of issues from security, data availability, connectivity. And a lot of times, we're dealing with what's, a lot of places, basically manage across with the IS A95 Purdue model. And, as people have seen this, there's a lot of different pictures and diagrams that this represents, but basically what it is trying to segmenting the different layers of operational connectivity of OT data to IT networks and business enterprises. Obviously at the low level, you always have sensors, actuators, you have, either controllers, PLCs, HMIs, SCADA operations, and you typically have a DMZ zone, and then you have like a business layer, then you have like the cloud layer from that standpoint. And all these, have different applications in them. They have different requirements in them. They're doing different things. But at the end of the day, they're kind of different in the sense that OT is a very secure, isolated network with a lot of kernel knowledge that are very cryptic protocols and operations that don't really follow, what's up top at the different levels, but there's still the demand for the data. And if you, let's see if I have control. I do not have control. Go ahead, next slide. Go ahead and click. So you have all these applications and all these consumers of data that want to be fed. And we're dealing with the security mechanisms. We have a lot of business drivers that are trying to drive this in predictive maintenance, Industry 4.0, all those different scenarios. Go ahead and go back one, Arlen.
Okay.
And so you have big data, you have all these different consumers of data, and yet you still have the ISA Purdue model. You still have these segregated, kernel knowledge and protocols, but yet demand for data. And a lot of times operation is dealing more in just real-time control. So they're not really concerned with all the meta properties, the modeling, and all the different characteristics that a lot of these other IT consuming projects need. And and it's been a big pain and a driver of trying to enable Industry 4.0 or IoT and try to utilize this in a secure mechanism, especially with everything that's happened with like JBS and Colonial Pipeline and the state attacks that Alan was talking about. Is we're trying to find a way to make this kind of follow the Purdue model, but also provide the security and the data awareness that's required.
Okay, Kurt, I'm going to try to get control of this panel again. Hang on.
You can just go to the next slide while we're.
Well, yeah, hang on. Let me try to figure out what's going on here.
Well, we can go ahead and go through the slides. I mean, I don't think we.
Okay.
This is fine.
Okay. Hang on.
Go ahead and go to the next slide. So go on the next slide. You start out with the OT environment, and this is the kind of a typical cloud solution that we've seen. So you have all these users. It could be Azure, Microsoft, and they'll usually put a container and code down at the edge. And so this container and code, basically what they're doing is writing either some custom code scripting. It's managed. Go ahead and click through 3 of them. It's managed by IT. It is a lot of custom writing. They're using code that's in modulars, scripted. It's not in front of the OT. The OT people on the factory floor don't have any really strong visibility or control of it. It's kind of managed outside of their control. Not that it's IT is doing a bad thing. This is the kind of tools they're trying to use, but it's not. It's kind of breaking the ISA Purdue model to a certain standpoint because you don't really have OT involved. It takes a lot of time and money to build these codes. It becomes scalable issues because you're writing a POC or an application for a specific use case, but those use cases change. And if you have multiple factories, there's going to be a lot of times different protocols, different applications, different requirements, and then that doesn't really scale. So what you have is this is kind of the failure of people trying to do predictive maintenance or Industry 4.0. It gets to be very expensive, very costly, very slow to market, and a lot of those projects just end up failing. And so what we want to do is try to show you with this type of architectures, how does this really accomplish and the values that you get when you start using MQTT in this Purdue model. So if you go ahead and click, Arlen. So the idea is, so you're going to have level 3, and I know that Benson's going to talk about securing level 2 and level 1, which is there's not a lot of security, a lot of serial protocols and things of that nature. But what we're doing here is we're seeing DMZs and pushing up each layer being very critical. So what we're doing is from the layer 3 is we're going to push up the data that we want to push up with contextualize. So this is with MQTT and Sparkplug. So not only am I pushing it up as an outbound connection securely, TLS encrypted to the ACLs, but it's also pushing up a data awareness. So I have a Sparkplug that's doing a birth certificate that's telling me all my components, all my tags, all my information. So now when I push that up a layer, that layer on layer like 3.5 now has self-awareness of what is happening at the edge. So if I add new things at layer 3 or layer 2, and I have or make changes or make any kind of modifications, that stuff is self-aware to those applications on layer 3.5. They are just subscribing to that information. So as new tags change, as new devices are added, it's now become a self-learning, self-aware application. And the data that comes up, they don't have to go up there and pull or do anything. They just subscribe to the flow of data that they have access to that's self-describing, self-learning. Now, once you're on level 3.5, we can push it up to level, we can take a subset, all, some, or even data from 3.5 itself, which, and push that up to level 4. And the same thing applies. Now you have all your applications, your business applications, your things on the business side now are subscribing to that data. They're self-aware. There's no need, it's now as things are coming in, there's a birth of the data from the level below, and all those applications on level 4, go ahead and click, Arlen, are now just getting the data and it's self-aware again. So now I have data from level 3 that's publishing up to level 4, or level 3, 5 to 4, and all applications and environments are learning this data. And now we have this pushing up to layer 5, just the same scenario. We can take a subset, we can take information from the other applications in layer 4, we can push it to the cloud, and none of the layers above are connecting to the layer below. So it's not breaking into the ISA 95 Purdue Model laws and requirements. It's basically enabling this environment. So we have lots of projects that this is, they're using MQTT for this very reason. We're doing navigation systems on oil tankers. We're doing other stuff where they have multiple layers, and all this is to be critical so that you have a self-awareness of the data, a self-learning of the data, but also extreme security in the sense that everything is pushed up through the different layers. And this is becoming more critical as those business units are wanting that information. And now it's contextualized, as Arlen described in the spark plug. So not only are you getting the data self-aware, you get it described as a data object that's easily usable and consumable in those business applications. Okay, Arlen? Go to the next slide. So another thing that we're seeing a lot of, that this is an application that people are using MQTT for, is third-party applications. So we have a lot of companies that have third-party applications that want to consume some data, and they, from an IT perspective, Alan's point of view and looking at how IT is done, you don't really want to ever have your third-party company come in and connect to your control network, connect to your network, and do a VPN. Even though if you're doing a VPN connection, you don't want them connecting to an open space server. It's not necessarily the most secure thing, having an open socket connection into your network. So what they do, they're requiring these companies to put a broker on their network, and then they subscribe to the data as a third-party app, and the company that has the data on their level 3 or level 4 or level 5 are pushing this data outbound, and it's segregated. Only the data that they can see, they can actually select the data from the tags or from the environment of what these third-party apps can see. And so now they just set up a simple outbound connection that's TLS to their network and require no network connectivity, no VPNs, nothing, from a security standpoint coming into their network. So this is something that's widely being used with this type of technology. And I think with that, I am good. And now I'm going to pass it over for Benson's awesome presentation.
Yep. So, hey, Chris, can you make Benson presenter?
I'm all set.
All right.
Let's see if we can get it to connect here. Okay. Everybody can see me and see the slides? Get a thumbs up, you guys?
Yes, yes.
Terrific. All right, so first, thanks Arlen, thanks Kurt and Chris at Cirrus Link for this opportunity to talk a little bit about our role in cybersecurity, and certainly in MQTT messages. Arlen and I have known each other for decades, and so we're always excited to present together. So thanks, Arlen, for that. All right, let's jump right in. I'm going to go over here to my presentation. We just heard a little bit about the Purdue model. Now, real quickly, the reason why this was created was to solve a problem. Naturally, we had issues with devices that might be on the cell area or on the OT zone that were largely unsecure. So, literally 15 years ago, however long it's been, the Purdue model was put together to solve that problem. And it was effective. It was effective at zoning off devices that were largely unsecure from business apps and other business systems, and to provide some layers of security, among other things. The Purdue model is pretty broad. However, it can be sometimes complex to put in place. If you're a very large organization, like the organization that Alan's part of, it might be a little easier, and you have to abide by the rules and so on. But it certainly is more difficult for smaller shops. Yet, you shouldn't, just because you're a small shop, shouldn't mean a reason you can't implement these types of solutions. So what we see is that this notion of edge computing is starting to expand, embrace and extend the Purdue model all the way down to perhaps some of the lowest levels. And it does this largely because it's able to implement the same cybersecurity features that IT would implement on a traditional Purdue model all the way down at the edge. So this can be real helpful, particularly for small shops, because they can start putting these solutions and create cyber secure environments very, very quickly. And the important thing to remember here is that it works harmoniously with the traditional Purdue model. So we can move data, just as Kurt described, all the way up through the different layers with no connections back down. But we can also provide that kind of security right at the edge and push that data wherever it needs to be. Now, one of the IT technologies that's critical about this in this architecture, you heard it from Nathan, you heard it from Arlen, you also heard it from Kurt, now you get to hear it from me, and that is TLS architecture. And that's what we see on the screen here. This illustration is courtesy of the folks who helped put together the Purdue model. But I'm not going to go over all the details here, but what's important to note is this is well-known, trusted certificate environment. And now we have a way to take this kind of architecture and drive it all the way down to OT devices. So I'm about to start talking about how we're going to implement a secure architecture using various products, but that's not the story here, okay? This is not a product pitch for Opto products or anything. This is about a process. This is about putting together the right pieces. And as Bruce Schneier is famous for saying, security is a process, not a product. So we'll keep that in mind as I go through this next secure architecture build out. We'll start here. This is where we'll start with field assets, could be plant floor equipment, could be OEM machinery, could be remote geographically dispersed assets like wellheads. And then what we want to do is, obviously, we have some level of control in what we call the OT network zone. Now, we want to make sure that this OT network zone is completely isolated from any other network zones or any other actors on a given network. So generally, we close that network down. We give it static IPs because generally you're not going to see DHCP services in a zone like this. But the other big issue is there's potentially a lot of unsecure devices in that zone. For example, the Modbus device pictured there, I think I have my laser pointer, there it is. That Modbus device is port 502, that's not a secure port. So you want to make sure you're kind of zoning up unsecure devices. And then there's a lot of proprietary and industrial protocols that exist in this zone that, again, are not protected. But also the reality is we live in a brownfield world. So we have to apply technologies, whether there's cybersecurity, zoning, and so on, to legacy controls as well. So we can integrate those into the same platform. We're not going to rip and replace with some fancy new edge device existing controls. So we want to be able to embrace this architecture to protect those as well. So we need to implement OT assets, legacy assets as well. Now we also want to make sure that those are in their own zone. And as you can see in this illustration, there are literally 2 OT zones here that may not communicate with each other. So you really have a lot of flexibility in terms of how you start zoning this thing together. And we can provide communications between those 2 zones in MQTT, which I'll discuss later. So now the next step, and this is an important one. These edge devices have multiple network interfaces. So I can now use that to connect to an IT LAN or some other LAN that may be untrusted. Why? Because the edge device on that given port has the kind of security capabilities that you would normally find up in IT. I'm talking about firewalls, certificates, user authentication, multiple network interfaces, and valid gateways to other networks, right on the edge device. So here we're protecting we're basically zoning out the 2, the trusted network, the OT zone, and the untrusted network, the IT LAN. Now we start using that LAN with the valid gateway to start connecting to the DMZ. In the ISA model 3.5, it could be DMZ on premise, it could be cloud, and inside that DMZ are tons of servers. Servers that could be database servers, MQTT servers, VPN servers, and so on. And the other really kind of cool part about this is that you don't have to commit to just on-premise or the cloud, because these devices can connect to both simultaneously. Could be for redundancy, could be based on where you need the data to go, all of that. And it's also important to remember that all of these, in the DMZ and on the cloud and at the edge devices, firewalls aplenty. So we really have a lot of granular ways of blocking traffic that shouldn't go into a given device, and all the traffic that is going through any of these lines is authenticated and encrypted. So now once we've created that secure encrypted connection up to, let's say in this example, an MQTT broker at DMZ, at the DMZ or in the cloud, now I can start publishing messages on change from any of the devices in the OT zone. So not only have I zoned it and protected it that way, but now I have a way of moving that data over a tunneled encrypted connection. Now I add SCADA. Whatever SCADA is, MQTT Spark Be aware. Ignition is obviously the classic example, and they've been doing this a long time. But the beauty of Ignition is it also can take all of those MQTT tags and expose them as OPC UA tags. I'll actually be showing you a demo of that in a moment. But here's where it gets really interesting. Just one of the places it gets interesting. There's more. This is an MQTT application by another third-party company, Canary Labs in this case, so the maker of a historian. It's also MQTT aware. So it can plug into the same infrastructure on it going into the server, never directly coupling to any of the OT devices. We have all these layers in between, yet it can still grab any of the data from OT and start historizing it and providing that information to whoever it needs it. But the real important thing about IoT and digital transformation is scale. It doesn't make sense to, to put a lot of code or do the tooling for just a one-off thing. You have to be able to scale the solution. So as you add more, more system, in this case, it might be, this is actually real close to what Alan's doing, putting a Rio in front of a PLC. It's connected to the LAN, publishes its tags, and all the tags from that new zone are automatically available to the entire system. That's the beauty of MQTT and Spark Be messaging, is once I connect, I start publishing it, all the other applications can now consume it. Single source of truth, no re-entry of tags. Now that we've got this architecture in place, we're moving data around securely, think of the other things that you can do with this kind of architecture. For example, remote access. We've all been having to work from home. We have to log into some kind of system. How do we do that securely? Well, these edge devices, again, not only have that MQTT client making a secure encrypted connection to a server, but VPN clients as well. Making a connection into the VPN server in the DMZ, in the cloud, doesn't matter, makes a connection there. And then finally, the remote access computer makes a connection to the same VPN server using two-factor authentication, username, password, very secure access, and it gives them access to those devices on the back end. And then you can do one step further. We heard from Alan this morning about the potential for actually accessing the PLCs in the other zone. We can do that as well. So that's where we enable conduits on demand, again, from SCADA. So we're not doing anything automatic or on a timer, although we can time out the connection, but only when an authorized person over a secure encrypted connection sets the SCADA tag to say, enable a conduit or enable the VPN, does it happen, and then it times out. So the long and short of it is that there's a lot of functionality now down at the edge that gives you this flexibility to do some pretty interesting things, all because we've taken IT technologies and put them right down at the edge to provide that level of cybersecurity and control. Now, this is the Cirrus Link modules and different placements of where those modules exist throughout this type of ecosystem. There are devices as well that have native MQTT. We're one of them. We actually offer both. So you may use native MQTT for simpler applications, but for more sophisticated MQTT messaging, we suggest the MQTT transmission module with its store and forward, its multiple transmitters, multiple brokers, a lot of other configurations in there. It's pretty exciting. The next part of this is a live demonstration. So what I'm going to do is I'm going to actually refer to the same architecture drawings I just showed you, but I'm going to show them to you kind of in a browser here. So I'm going to click on that and hide this list. Now I'm just showing that, well, let me switch over my screen to there. There we go. And what you see here is a live demonstration of all this technology I just described in action. So behind me here, I've got some PLCs, and those of course are being represented by this top box up here. So I'll switch back. I have my PLCs on its own OT network. So this is kind of the red box, if you will. Then I've got my Epic here that's making the connection between the OT zone and the IT zone, as indicated by these Cat5 connections. The yellow one goes to the IT network, the blue one is to a private OT zone. I'll switch back, and then I'll show you how all of that is connected up over the IT LAN, connecting to a broker, and then we'll take a look at some of these other applications that are going to get data from here. So really the first step is to be able to log in and actually configure a device, an edge device, to do some of these tasks. So I'll show you how that works. I'm going to go to a shortcut, and it's just going to go to one of this Groove Epic that's actually down beneath me here, right there in the center. And as you can see, this is a secure connection. This is where certificates matter. There's a certificate inside the Groove Epic controller in this case, but it could be any edge device. There's a certificate in there that is verified from a certificate authority. So when I log in, I know that I'm not passing my password over an unencrypted connection. Just as Nathan described and Arlen, we don't want man-in-the-middle attacks. Terrific. I'm gonna go ahead and log in. There's the second part. First was encryption, second is authentication. I have to log in with a username and password. Now, I can log in with any of the given accounts on this system because there's some local accounts, but LDAP is also supported. LDAP is simply a really elegant way for IT to centrally manage accounts. So that's in here as well. And you can set up different users for different tasks and different kinds of privileges to the system. Okay, lots to cover, so I'm gonna go back and go the next part, which was how do we set up that network? So I go to System, go to Network, and here we are. And as you can see, I have 3 different network interfaces, just as I described in the video below. Ethernet 0 there on a static IP address space, non-routable on its own OT zone, no chance for you can't even have any of those systems get out on the network. The second one is down here on Ethernet 1. This is a DHCP'd address, meaning I got an IP address from IT. That also means that IT can audit what IP addresses are passed out and monitor that situation all the time. Finally, an OpenVPN client built right into the device that's tunneling out over that valid gateway and making a connection to the VPN server, allowing it to join the VPN network. So pretty cool stuff there, but that's not the whole story. The other part of it is you have to have certificates, as we described, but a firewall. So the beauty of the firewall in this case is that each of the different ports on any of the given interfaces have a firewall. So I can be very granular about what kind of data I will allow it to move around any zone. In fact, what we always recommend is even on this zone here, as I'm describing it, let's just call it the IT network zone, this green area, that shouldn't allow any connections to the OT zone unless it's secure and encrypted and authenticated. Cut and dried. No other open ports. In fact, you can actually even close the secure ports if you wish, and literally not be able to get to the device at all, but it can do all outbound communications just fine. Okay, so the firewall is really important, and it's very granular based on each of the different interfaces that are supported on the given hardware. Okay, so that's a little bit about the firewalls, the security. As I said, the client server certs are in there, and what's beautiful, what's really nice about this type of integration, I would look for this on any edge device you're looking at, is how do you manage server certificates? How do you create a CSR, a certificate signing request? How do you grab the certificate back from IT and get it installed? All that kind of stuff is built into these interfaces. Okay, then there was one other part that I talked about that won't be able to get a lot of detail in, but it was the idea of the conduit. So once I create, let's say, a VPN tunnel into a given device, I may want to be able to access these devices on the back through something called a conduit. And that conduit will transfer information over so I can get access to the PLCs on an on-demand only basis. And that, of course, is configured here. At this point, it's disabled as it should be. There's no reason to have any ports conduited when somebody's not using it. But when I want to use it, I should be able to log in securely into SCADA. In this case, I'm just using the local HMI, and I'll go over to the conduits, and I have a screen with a warning that says, hey, if you enable these conduits, you're going to get to the PLC network, but it's on demand, and it's secure, and it's logged who the user was that did this. You can do this through Ignition. You can do it through a number of different ways. So I'll go ahead and enable the conduit, come back to here, look at my system, my port forwards, and there they are. So a lot of information there, but really a way to get all this data moving in the direction it needs to go, which is outbound up to a DMZ or cloud, and start doing something interesting with the data. Let's see, I've got just about 2 minutes left here. So real quickly, I'm gonna open up a couple of applications that actually use this. We'll drop in a link so you can actually see this is a public website that's consuming all the data. So I'm logging into this server down here. Let's take the VPN and conduits off and put the MQTT traffic on. I'm logging into this server down here on the bottom. I'm going to log in securely, username and password, to this server, and I can see I've got coming to our demo site. I'll go to Epic Opto Turbine. This data on the screen is the data from this secured zone, including the AB PLC data and the Siemens PLC data. No chance I can get to it because it's behind all these layers and all this security. Yet check this out. I can send a command to that PLC from this public-facing website that is secure. And let me give you an example. Down here on the bottom right there, there's a green stack light on that's connected to the Siemens. I'm going to click on the red stack light. So from SCADA, I'm going to send a message through the MQTT broker. It'll be consumed over on the edge device side, and then send the command to the Allen Bradley controller. Let's take a look. 3, 2, 1, click. And just that fast. So imagine all these layers of security, all this encryption, everything that's going on, yet I still have high performance. That is really amazing. So it gives us a sense of how we're pulling data from legacy devices, or perhaps how we can simply control devices. And you're welcome to get in there and do it yourself. Trial is the username, Opto22 is the password. And now you can see I'm able to do interaction with devices that are highly protected, and it's all encrypted and all security. One last thing to close out, and this is my last thing I'm going to be able to pull off. I said on this screen right here that even the historian is connected. So let's just take a quick look at the historian. So I'll go into here. Once again, I'm going to be required to log in with the username and password, assuming that I can make a connection here. And there we go. And check this out. This is the historian, a completely separate application, still secure, subscribing to data from the broker, pulling in all the OT data, and there I go. Even my true false for my port forward, my conduit. So now I've also logged it in a historian, who did it, when it happened, everything. So now we've really built a highly secure system here. I'm out of time, so I'm going to kick it back over to Arlen for any Q&A. So let me go ahead and.
Benson, thanks. As always, awesome. So yeah, we just have a few minutes left here. I know that one of the questions that came up was about denial of service attacks on MQTT, and I don't think really denial of service attacks are going. I mean, it doesn't matter if you're using MQTT or anything else. That's always a concern, but I think that if you look at what Kurt went through, if you look at what Benson just went through, is that if your IT architecture is built from the ground up using the Purdue model, using the proper firewalling, I think that's going to minimize especially external denial of service attacks. I think if you have an internal denial of service attack, you probably have other problems you've got to deal with. So let's see, one of the other questions real quick, Nathan, I'll kick it over to you. Somebody asked, how do they generate their own TLS certs?
Sure. So you can either stand up a test CA, a certificate authority, and there's some fairly good tutorials out there on how to do that, generate all the appropriate certs. A lot of companies, of course, have their own internal CA, or of course you can reach out to the big guys, DigiCert, for example, to get your TLS, your SSL certificates.
There's another question that I'd like to give to Benson is, we had questions on, how prolific is this, MQTT and Sparkplug, and I think it'd be a question for Benson to say, since he's not Cirrus Link, a little bit outside partner, and being in the controls business of building, Opto22 for as long as you have, what have you seen from a use case scenario of MQTT and Sparkplug recently?
The adoption's been incredible, and it's not just because, you know, the pub sub model, the data on change, the state management, all the beautiful things about the MQTT. It comes down to people are now addressing cybersecurity using MQTT, and I think that's what's important, because it is an outbound connection. People are basically able to, you know, pardon the phrase, but kill two birds with one stone here, and that's an important consideration. But adoption has been remarkable. We have more and more companies that are putting this in because it's so much easier to say tilt up an MQTT server today. It's really taken off, and we're just thrilled to be part of the Sparkplug working group to further extend and grow the capabilities of these technologies.
All right.
I think we're done, Arlen.
Yeah,
go ahead.
thanks everybody. I really appreciate it. Thanks, Alan. Thanks, Benson. Really appreciate it. So that's the end of our webinar, and everybody have a good rest of your day.
You as well. Thank you.
Thank you.